Hello everybody and welcome to the second video for cumulative review number 15. We're going to start here with number 12 where the directions are just to factor the following polynomials. And before I start, I want to remind you what to look for when you factor. First thing, always GCF. Second thing, perfect squares. Third thing, if possible, if you have a lead number of 1, you can factor very quickly into 2 parentheses. And then last but not least, if you have nothing else to do, you have to do the method of split the middle term. And all of these are going to come up in these factoring problems. So if I start here with number 12, the first thing I want to look for is a greatest common factor. So when I look at all 3 terms, I know it looks a little strange, so I'm going to start with GCF. I look at 18, 12, and 6, and I think the biggest number I can take out of all 3 is 6. If I look at x to the 5th, x cubed, and x, I can take a single x out of all 3. Y to the 7th, y cubed, y squared, I can take 2 y's out. So now I would end up dividing the numbers and subtracting the exponents. 18 divided by 6 is 3. 1x out of 5 is 4 remaining. 2 y's out of 7 is 5 remaining. Plus 12 divided by 6 is 2. 1x out of 3 is x squared. 2 y's out of 1 y is just 1 y left over. Minus 6 divided by 6 is 1. X divided by x is gone. Y squared divided by y squared is gone. So I'm going to close my parenthesis. Then I'm going to look at what's remaining in my parentheses and see if I can keep factoring that. This does not look like something we could continue to factor because I do not see an x squared, which means this is my final answer. And so this was the first type of factoring that we did, just taking out a GCF. Number 13, I notice that there are 1, 2, 3, 4 terms, none of which are exactly like terms. So this means that I'm going to do grouping if possible. I know that was not one of my 4 options, but I think a lot of you know by now that 4 terms usually leads to grouping. And grouping really leads to greatest common factor again. If I look at my first 2 terms, I can take out a single x, and when I do that, I'm left with y minus 2z. In my second 2 terms, I can take out a 5, and then I'm left with y minus 2z again. Now remember, this middle sign always carries down. If this was a minus, this would be a minus down here. Now, these 2 parentheses match exactly, so one of my factors is y minus 2z, and my other factor is what's remaining, the x plus 5. There are no x squareds or y squareds left, so I am done factoring here. Number 14, do I have a greatest common factor? No. Do I have perfect squares on the ends? No. Do I have a lead number of 1? Yes, I do. So I can go straight to 2 parentheses and think about what multiplies to be 24 and adds or combines to be negative 10. Well, my options for 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. These 2 options can get me to a negative 10. However, only negative 4 and negative 6 would get me to adding to be negative 10 and multiplying to be a positive 12. So this is the pair that I would pick. I would write a minus 4, a minus 6, and be done here, because this is not factor and solve, it is just factor. And remember, if you'd like to check your answer, you could always multiply it back out or distribute to see if you get back to the original answer. If I look at 15, again, first thing I look for is greatest common factor. So I look at all 3 terms. I notice that I can take a 3 out of everything. Notice I'm not dividing by 3 because this is not an equation, it's an expression. If I take a 3 out, I'm left with x squared plus 9x plus 20. When I look and see what remains in the parentheses, I notice I do have an x squared, which makes me think that I can continue to factor. And just like number 14, I have a lead number that has a 1 in front. So I again can go straight to 2 parentheses. What I think about is what multiplies to be 20 and adds to be 9. Well, the options for 20 are 1 and 20, 2 and 10, and 4 and 5. 4 and 5 is the only pair that works. x plus 4, x plus 5. I am done here because I no longer see any x squareds, and it's not an equation, so I am not solving. Number 16. I look at this option and I say, okay, first, do I have a greatest common factor? No. Do I have perfect squares on the ends? No. Do I have a lead number of 1? No. Can I group this? Not yet, because there's not 4 terms, which leads me to the option of split the middle term. And the first thing we want to do for split the middle is multiply a times c. 6 times 12 is 72. My options for 72 are 1 times 72, 2 times 36. 72 divided by 3 is 24. 72 divided by 4 is 18. 5 does not go in. 6 does. 6 times 12. And then finally 8 times 9. Which one of these pairs, just like the other factoring, ends up adding to be negative 17? I think it is just this pair that'll work. Negative 8 and negative 9 adds to negative 17. Negative 8 times negative 9 is a positive 72. So again, the reason the method's called split the middle is because we literally split the middle term into 2 parts. Into these 2 parts specifically, to negative 8y minus 9y, and then we bring down what was already there. The first term was 6y squared, the last term is 12. And now we created a grouping problem. So we group these 2 together, group those 2 together, take a greatest common factor out of both. My GCF of these first 2 would be 2y, and I would be left with 3y minus 4. Carry down the minus sign. So I'm really taking out a negative 3 here. Negative 3 out of negative 9 is a 3y. Negative 3 out of a positive 12 is negative 4. So again, I know this is correct because my 2 parentheses match. So my factors would be 3y minus 4, and what's remaining? 2y minus 3. This is my final answer, because again, I'm not solving, and I do not have any more squares to factor. Number 17, let's go through the checklist. Do I have a GCF? No. Do I have perfect squares on the ends? Yes, I do. And I want to remind you that this problem really means that there's no middle term. So it really means the middle term is 0 or 0x. Because I have perfect squares on the ends, I again can go directly to 2 parentheses. We don't need to split the middle. And the square root of 49 is 7. Square root of x squared is x. So the front of both parentheses would be 7x times 7x, because those 2 together are 49x squared. 4 times 4 gives me 16. Whenever I have a middle term of 0, I always have 1 plus and 1 minus. So this would be number 17 factored correctly. Number 18, I look at this and I say again, first, do I have a GCF? Yes, I do. I can take a 2 out of everything. And if I do, I'm left with 25y squared minus 30y plus 9. And then when I look at what I'm left with, I notice I do have a squared term, so I may be able to keep factoring. Let's try it. I notice that 25 and 9 are perfect squares. So why don't we treat 18 like 17 and split this into perfect and perfect? 5y times 5y in the front would give me 25y squared. 3 times 3 in the back would give me 9. Here is a 15. Here is a 15. How do I get 15y and 15y to be negative 30y? If they're both negative. And some of you have noticed a pattern with the perfect squares that if there's no middle term, you always have one positive, one negative. If you have a middle term, take a look to see if your middle term is negative, because if it is, your final answer will have 2 negatives. If this is a positive, your final answer will have 2 plus signs. Now this is not the final answer yet. I would say the best final answer you could possibly have is 2 times 5y minus 3 quantity squared, because it occurs twice. Number 19, I notice that I do have x to the 4th, which is a little intimidating, but let's still go through our checklist. We do not have a greatest common factor, but again, we do have perfect squares. This problem is really saying 81x to the fourth plus 0 in the middle minus 16, technically 0x squared if we're doing standard form. I can go straight to two parentheses. 9x squared times 9x squared is 81x to the fourth. 4 times 4 is really negative 16. I need 1 plus and 1 minus to get the middle term of 0. Now this is the tricky part. It's really tempting to say that you're done here. And in fact, this first parenthesis, whenever I see a plus sign, I know I am done here. So I know that 9x squared plus 4 will be in my final answer. However, this piece can continue factoring because I have perfect squares again. And I'll go into why we can factor this one and not this one in just a second. So if I continue factoring this one, it would be 3x times 3x is 9x squared. 2 times 2 is 4. Positive and negative, because again, my middle term is technically 0x. So this would be my final answer for 19. And the reason, again, that we can continue factoring this one but not this one is because if you look at what we did in the green, positive 2 times negative 2 is always a negative 4. And if I want a middle term of 0, there's no way that I can get a positive 4 because one's always positive and one's always negative. So whenever you see a plus here, you can no longer continue factoring this problem. Numbers 20 to 23 are solving quadratics. So you can choose whichever method you'd like. We can try factoring first, completing the square, and the quadratic formula. Quadratic formula, not quadratics formula. I guess technically it's the same, but whatever. Anyway, first thing I would do for number 20 is just to see if it factors first. I'd always try factoring because you and I both know it's generally the fastest way. So if I look at number 20, it looks odd to me. So let's try factoring. First again, let's think GCF. We just did it on the last page, so why not continue? Do I have a greatest common factor? Yes, I do. 4 and x. And if I take that out of both, I'd be left with 1x minus 4 equals 0. Because this no longer has squareds, I don't have to factor anymore. But I can use the zero product property and set both pieces equal to 0. 4x equals 0, x minus 4 equals 0. 0 divided by 4 is 0, so one answer is 0. And if I add the 4, the other answer is positive 4. Number 21. Again, first thing I'm going to try is factoring. I look at all of my terms, and just like number 20, it's equal to 0, which is promising for factoring. I notice I do have a greatest common factor of 3 and x. So if I take that out of all three, I'd be left with x squared plus x, or 1x, minus 20 equals 0. I do have an x squared left over, so let's see if I can continue factoring into two parentheses. So again, we're thinking what multiplies to be negative 20 and adds to be 1. There's technically a 1 there. X times x is x squared. 4 times 5 is 20, and to get a 1, I need a positive 5 and a negative 4. So at this point, I can set all three pieces equal to 0. 3x equals 0, x minus 4 equals 0, and x plus 5 equals 0. So my answers would be 0, add the 4, positive 4, subtract the 5, negative 5. So because this originally is a cubic, it makes sense that there are three possible answers. So again, I'm going to pause the video here and I'm going to continue with number 22 on the next video. Thank you.